Hey everyone, in this mini lecture we're going to be discussing convex quadrilaterals. So specifically, the theorem we're going to look at is the interior angle sum of a convex quadrilateral. So I'll just draw a quick sketch of what one may look like. So this is a quick sketch of a convex quadrilateral. Alright, so within this type of quadrilateral, it's a four-sided polygon where the interior angles, and I'm referring to the angles right inside here like that, those interior angles are all less than 180 degrees, right? This is a convex quadrilateral as opposed to another type, which would be maybe a concave quadrilateral, which one of those would have an angle that is greater than 180 on the inside. But all of these interior angles are less than 180 degrees for a convex quadrilateral. Also, all four of these angles, we'll call them angle 1, 2, 3, and 4, whatever degrees they may be, whatever measure they may be, all add up to 360 degrees. Right? So the sum is 360 degrees. Alright, so I can say that if I were to measure angle 1 and add it to the measure of angle 2, add it to the measure of angle 3, and add it to the measure of angle 4, they should all sum up to 360. So this is a quick overview of this theorem of the interior angle sum of a convex quadrilateral. So in this example, we're given the following quadrilateral ABCD. Angle A is 90 degrees, angle D is 90 degrees, angle B is 62 degrees, and angle C is unknown. That's the measure of the angle that we're trying to find. So based on what we just discussed in the introduction to the theorem, we're going to say that the measure of angle C is equal to 360 degrees minus the measure of angle A plus the measure of angle B plus the measure of angle D. Right? Since all four of the angles inside of this convex quadrilateral have to add up to 360, we can subtract all of the other ones that we do know from 360, and that'll leave us the one that we're looking for. So we get 360 degrees minus angle A, we said is 90 degrees. We know it's 90 because it's marked 90 degrees with that box. And then the measure of angle B is given also at 62 degrees. And the measure of angle D is also marked with the right angle box as well for being 90 degrees. And now it's just a matter of taking the sum of everything in the parentheses and then taking it away from the 360. So we get 242 inside of the parentheses, and we take it away from 360, and that leaves us with 118 degrees. So the measure of angle C is 118 degrees. In this next example, we're given quadrilateral ABCD. Angle A is given as 103 degrees, B is given as 90, C is the unknown, and angle D is 60 degrees. So once again, to find the measure of angle C, we're going to add up all of the other angles that we do know and then subtract it from 360. So we take 360 and say 360 minus 103 degrees plus the 60 degrees plus the 90 degrees. Alright, and then we'll just crunch the numbers. So 360 degrees minus the 103 plus 60 plus 90 is 253, and then that leaves us with 107 degrees. Alright, so the measure of angle C, that unknown, is 107 degrees. In this next example, we're given a convex quadrilateral, but then there's shown here the extension of this line going a little bit past that angle Z. So we have this angle at 110 degrees, and then we have Z, the unknown, Y is an unknown, and we have a 100-degree angle and an 87-degree angle. So we are asked to find Z and Y, those two angle measures. Well, I know that 110-degree angle added to that unknown Z degree angle, they're what's known as supplementary angles, right? The measurement of those two angles combined should add up to 180 degrees to form a straight line. So I can write that in an equation. So 110 degrees plus Z, the unknown, is equal to 180 degrees. So we just do a little algebra and solve for Z. So here Z is equal to 180 minus the 110. So Z is equal to 70 degrees. Alright, so now I know what Z is, and I know that this is an 87-degree angle to the bottom right. Top right is a 100-degree angle. Top left is still unknown for me. I'm trying to find that Y degrees. So given that Z is 70 degrees, I could say that Y degrees plus Z degrees plus the 100 degrees plus the 87 degrees are all equal to 360 degrees, because we just stated that earlier in the theorem for a convex quadrilateral. All of these interior angles have to add up to 360. So now I'm just going to perform a little bit more algebra, combine everything that I do know. So Y degrees plus that Z is 70 plus 100 plus 87 equals 360. These three are my like terms. I'll just go ahead and take care of those, and I get about 257, right? And that's equal to 360. And going ahead and solving for Y, I get Y is equal to 103 degrees. This final example is showing another convex quadrilateral. However, the angles given have variables within them. So we have angle E is x plus 16 degrees, angle G is 2x plus 10 degrees, H is 2x plus 10 degrees, and F is x degrees. So once again, knowing that these all have to add up to 360, I can make an equation where I say x plus 2x plus 10 plus the other angle of 2x plus 10 plus the angle of x plus 16 all add up to 360 degrees. Alright, just combining like terms a bit, the x, the 2x, and the 2x, and then that x. That gives me about 2, 4, 5, 6x. Other like terms are the constants, 10, 10, and 16. Give me 36, and as we stated, they add up to 360. Performing a little algebra, we get 6x equals 324, and then x is equal to 54 degrees. So we found what x was. That's all fine and dandy. However, we have to always follow the directions in the word problem and look for whatever else they're asking for. They're asking for all the other unknown angles, which are the rest of the angles. So we're looking for the measure of angle F, and we found that to be 54 degrees because angle F was x. Alright, now the measure of angle H, if you look and see what it was, that was 2x plus 10 degrees. Right, 2x plus 10 degrees. So we just go ahead and substitute a 54 in for x. So we have 2 times 54 plus 10, and that gets us 118 degrees. 118 degrees. Alright, and then lastly we can find the measure of angle E, and angle E is x plus 16 degrees. right? So x plus 16 degrees. So we just plug in 54 plus 16 degrees, and we get 70 degrees. And angle G is actually the same as angle H, the 2x plus 10, so that's 118 degrees as well.